All right, you got your host here, the Sissy, and what I want to do is go over a kind of like a basic wiring layer, and how an electronic wiring circuit can control the most basic, or pretty much what I consider the most basic thing in this game of shapes.io, which I think IO is input output, just a guess of mine. And you got your date. The date today is 6/22/21. Yeah, because yesterday was 6/21/21. Kind of cool. So anyway, let me start the stopwatch. What they call it a stopwatch, but it's also a start stopwatch. So we're going to start it, just so I know how long the video is going. All right, we're going to go over now. The main video that I did, which I'll put a link onto it, these two link together. This will be way more of a basic video on how a wiring can control something. Because if you don't grasp that, it'll confuse you if you don't grasp it. And for those who do not have electronics background, this game really doesn't require much electronics knowledge, really, because they're already built for you in the game. But it kind of helps to know it first. I got my degree in electronics, so I have logic circuits and all that in my knowledge base. But because I have a degree, but it's not necessary for this game, because you don't have to actually understand. In this game, you don't have to understand on how it works. You just have to know what it does. And in actual electronics, you have to take actual transistor circuits and put them together into a point where you can make these electronic devices in the game itself. But we don't need to get down to the actual components down there. We don't need that for this. So this particular video I'm going to do is I'm going to control something with an electronic signal with a wire. So I'm going to do something here that will do that. So let me get rid of this and get rid of this. And I'm going to set this up. I'm going to set this up here. So what we're going to do is we're going to control how a circle part here, this gray circle, or uncolored, I should say, gets sent up here to this trash can. We're gonna use a wiring system to control it that only circles can get up here. And that's like the basic concept of wiring. And we're going to do that with the tools that they give us in the electronics of this game. And by the way, these are actual real things. When they call this an AND gate, that's for real. They really have AND gates. And an OR gate, a NOT gate, an XOR gate. So it used to be different. The naming has changed over the years slightly. The AND is still an AND, OR is still an OR. But there used to be a NOR gate, and I think that's... Then they have the XOR gate. But these are very useful. Basically, what these gates do is, let's say you have an AND gate. And this is the most basic. It only has 2 inputs and 1 output. There are AND gates with multiple inputs. What an AND gate does, it says, hey, if I get a signal here and here, they both have to be good before I get one out over here. That's how an AND gate operates. I need AND. I need this and this to get this. As an example, we'll get a piece of wiring, and we'll put it here, and we'll put it here. We're going to bend them a little bit to get fancy. Isn't that fancy? Now, this game also happens to have a signal generator. It sends out something. Anything we want as a choice. We can send out whatever we want by choice. And those are in real life also. So we're going to rotate this, and we're going to say, hey, we're going to go right there. So what do we want to send? Let's send a 1 signal. In electronics, there's zeros and ones. That's it. For the most part. That's just say that's it. It's called a binary system, where you can have a ground or a negative or whatever, a grounded signal, or a +1 signal. Usually it's, I could just say 5 volts or ground. Ground, 5 volts. Ground, 5 volts. Let's just say 5 volts coming out of a transistor circuit. So this machine is already built for us, makes it easy. I didn't choose anything. Let's choose a 1. All right, so we have a signal, and this is we get a wire over here. We have an output here of this AND gate. Right now, it says, no, I have a 0 out. I have nothing. I have a 0. I'm not giving you a 1. Because it's an AND, it says AND right on it, the ampersand sign. It's an AND. So I would have to have another signal over here. And if I make it a 0, no, not going to work. I still have a 0 because I don't have a 1 and a 1. So we go back to this one and make it a 1. Now we have a 1 coming out. This is very useful. Used all the time. It says, look, if I got a 1, and if I got a yes and a yes, I'll put out a yes. It's almost like talking to two people and getting the results. If they both say yes to something, then I will return a yes to the boss. Yeah, that person said yes, and this person said yes, so it is overwhelmingly a yes, so we get a yes. Let's go to the OR signal, OR. And the name is exactly what it sounds like. There's an OR gate. OR gate. Well, this is the same thing, except if either input is a 1, I'll get a 1 on the output. This is more easy to handle. This is, okay, well, if I have a signal, let's put a 1 in there. It goes on. Look at that. It's already a 1. Well, what happens if we do another signal generator and make it a 1 also? I still got a 1 because either one is a 1, I give you a 1. The boss said, hey, if either of those two people say yes to something, that's good enough for me, and I'll say yes to the output. This is the AND gate. They both have to be on before I get an on the output. Either or, yes, I get a 1. The other gates are just basically almost the same, but in reversed. For instance, if I got a 0 and a 0, I'll get a 1. They're different. The gates are different. But then another gate we have is an inverter, or I call what they call an inverter. What I call an inverter is a NOT gate. The NOT gate inverts the signal, whatever it is. So the NOT gate says, look, if whatever I get coming in, I'm going to invert it. So notice the output up here is a 0, but yet I have 2 1s coming in. This can be very useful. You can turn things on and off. If this is true and this is true, then this is false. If this is true and this is true, this is true. But all this gate does is say, whatever you give me, I'm gonna switch it to the opposite way. Same warm coffee. So anyway, let's look at the now this thing here, this inverter, or better known as a NOT gate. Then the last one that they have in here is they have an XOR gate. It emits a 1. if one of the inputs is truthy, but not both. So it's very similar to an OR gate, except for the fact that if they're both turned on, it does not give you a 1. So it's kind of like an OR gate with an extra clause in it. So we have a signal coming out of here, and we have a signal generator, and we'll put a 1 on that. Look, it goes 1. If it, like it says, if I get a 1 on either input, I'll output a 1. But in this case, this guy says if I get 2 1s, I will not give it. So if I go to a signal generator and I put another one in with a 1 on it again, it says, nope, they're both the same. Nope, not going to work. Now, why am I going over all this? Well, this is all very necessary. Once you understand the concepts and what you can do with these things, they will make the world great for you in this game. They will make decisions on the fly for you, but you have to design it still. You still have to design your thing. But these will work for you whenever you need them. Now that's that one. So now let's change this to a 0. Now it gives you a 1. It's similar to the OR gate. So these are the basic gates that they have in the game. AND gate, the OR gate, the NOT gate, and the XOR gate. And these are, like I said, these are all real life things. These are very useful in computers and everything else. These are the basic building blocks in real life of all electronics. If you understand these, and they're not hard to understand, then you got the basics of electronics down. This is the basic building blocks. But we're not getting into the actual circuitry of how you make that, but it's made with transistors and stuff. And a bunch of little circuits and things. Now you also have a transistor in this game, a very basic transistor, okay? It sort of acts like these as a group. This acts as an input, this acts as an input, this acts as a transistor. It says it forwards the bottom input if the side input is truthy. Now it can do also a color or a shape. And what this does is, this device, now in real life, a transistor does have 3 leads. There's a collector, the emitter, the collector, and the base. Let's just say, for example, each of these wires has a name to it. The emitter, collector, and the base. The base is your controller. The transistor will let current flow through it if it's told to by what's coming into its input. Now in this game, again, it's very basic. We're not getting down to the nitty-gritty here of what actually sets this all up to happen. And in this game, it just happens. So we have to get a wire here. We'll put a wire. We'll put another wire. And we'll put a wire. Keep things separated. Now it says up there, it transfers signals which can be items, colors, or booleans. Differently colored wires do not connect. Oh, that's a wire. What am I doing? A transistor. I had the wrong one. It forwards the bottom input if the side input is truthy. Well, what does that really mean? Let's take a look at it. Let's go back to our wire and stretch this way because we're getting too close to our other stuff. All right. Whatever this is here, whatever's coming in here, it will send it through this device and out if something is coming in here, something. We want an output to go from here through the transistor and out to here. Right now it's not doing anything. Remember the AND gate needed the XOR gate. Now the AND gate is a little bit different. Notice it says it will give you a 1 if both inputs are truthy. Or it does have a shape or color. Okay. So let's see. Let's change this to a red. Okay. So this AND gate doesn't care. As long as there's something here and something here together, it sets out. But the trick to that is the AND gate, it emits a 1. Emits, it gives out a 1 only if both inputs are truthy. That's a little different than real life a little bit. Usually it's a 1 and a 1, but in this game they let you mix this, so they let you go with a 1 or. So anyway, if there's something coming in here and something coming in here, this AND gate will put a 1 here, which can be a great decision maker. You'll find many uses for that in this game. Let's get back to this transistor. The transistor says it forwards the bottom input if the side input is truthy. All right, so let's put something at the bottom input. I don't care what, just something. Let's generate a signal of color green. Okay, I just picked that by just chance. It's got a green, and right now we're not passing the green. But when will this transistor pass a green signal? These are decisions that need to be made by the machine that you're going to build. Well, what happens if we stick another signal generator at the input of this thing to turn the transistor on and have it send out its green color? So let's put this here. Now what do we want to put into it? Let's try yellow. Didn't matter, did it? I can put yellow into it as long as it has something. I don't care. Just not nothing. This could be very useful in the game. If I got something coming into the transistor, I don't care what it is. Well, let's try a 0. Nope. A 0 is not going to make it work. We got no output. All right. Now, let's have a little extra fun here. Let's use it's a signal. What do we want to do? We want to. Okay. All right. Anyway, that's how the transistor works. Now let's get back to let's go apply our electronics for real now. Let's actually really take an electronic part because these are all electronic signals. That's nothing. They're not real parts yet. We need to get to real parts, and that's going to be our signal. Now, if you refer back, when you get done with this one and you refer back, you'll see with the analyzers will analyze the shape coming out of the hub. And that shape analyzer, and if you rotate the parts, it will analyze the different quadrants of the shapes and their colors, and you will apply this principle we're doing right here, but on a much grander scale. But if you don't get the basics, you won't be able to go any further. So anyway, let's go ahead and do our first electronic controller. We'll use a filter, and we're going to put it right there. And we're going to connect an input into it. What we're going to try to do is say, look, anything coming through me, I want to turn it on, I want to pass it. I don't care what it is. Let me fill this in here. Okay. Anything coming through me, I want to pass it. If I got anything on this belt, I want to pass it through. That's for starters. So we're going to go to our electronics layer, and we're going to take a signal generator for now, put it right there, and I don't care what it is. I put a 1 on it. It's got a signal, and I'm going to send that to the filter, and the filter says, "Okay, I'm on. I'm turned on." So with the voltage or this positive signal being sent here, it's a 1 signal. It tells this filter to pass. It tells it actually to pass everything. It just says, "Come on through." But we can be more specific. We can be more specific, not to be confused with Pacific. So what if we want to only pass See, it's passing everything. Shapes, all kind of stuff it's passing. What if we only want to filter out and only pass the circles? We're getting this other shape in here. Squiggly looking shape. Let's make this a little better on the eye. Let's do this instead. Let's keep this between circles and squares. There. All right, so now look what we're getting. We're getting circles and squares, and we're passing them. But you know what? I don't want them squares to be sent up here. I want just circles. So let's control them now. This is our very first, our first filter actually working as a filter. So let's go into electronics. And we're going to change our signal generator to, instead of a 1 that just says, yes, pass everything, I want to filter it so it only passes circles. Well, I can't pick that out. I can't find circles. I can pass a color. I can pass any one of the colors. So if those parts were different, but I don't have a circle. This is one part of the game that gets a little bit confusing, but once you see it, it's not bad. Once you analyze it and study it a little bit, it's like, oh, okay. Because the game has to generate a code for every shape. And sometimes you need to manually type it in order to get it. They have a link that it can send you to right here. I want a circle, but I can't choose a circle, so I need to make my own. And you could generate your own shape here. So let's go there, which is going to take us online. It just so happens to start out with a circle. Now, any shape that you see on the left here gives us its corresponding code up here, this 8-digit code. And it repeats, CU, 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 CU. Reason it repeats is because this repeats. You start at this quadrant and you work like a clock. You start here and you work your way around. There's 4 different quadrants. Now always keep in mind in this game there's also 4 layers. We're just keeping this simple at 1 layer. So here we have our 4 quadrants. Now why is this a CU? Why is that? Well, the legend over here on the right, it says circle, which is a C for the C up there. And then the color in this case is gray or no color at all. And it's uncolored, which in the legend it shows you giving it a U. So you can see by all these colors and all these different parts, you can get quite a few different shapes. Because you have the fan and the windmill, I guess, windmill / fan as they call it. So we would, in the game, you actually need to extract all the shapes that you need prior to building your big machine to make the parts automatically. So you're going to have a warehouse of those stored somewhere and all feeding it and get it ready to feed on the belts, to bring it into your machine to operate on these things and manipulate them as you will, as also the colors. But this part here, we're just going to do a baby thing here. So we need a circle in our analyzed part there. So if we go back and type this shape in here, we'll have a circle. Now, if each quadrant is a CU, so it's a circle, basically a circle part, really. It should say quarter circle, but it says circle and uncolored. So each one of these is identical. If I wanted to change this shape around and notice I'm gonna take these CUs later and put them into our filter. But right now, we're gonna change the shape of this while we're online. So let's say we wanted at the top right quadrant, we wanted a square instead. So we wanted square, circle, circle, circle. Okay, square, circle, circle. Okay, how do we make the top quadrant a square? Well, we go to here. In this case, it's rectangle, I should have said. We have to make it an R, U. U means the color. So if I want it to remain gray, whatever, I'll put a U after it, small case U. And R, capital R for rectangle. And since the quadrant starts here and works its way this way, this is the first two, which would be the first CU. So all I have to really do is change the C to an R. So let me backspace one, or delete. And now I'm going to type in an R for rectangle. Now look at that. We changed our shape. Now this code up here is not copyable because we're in Windows right now. We're in Windows. So since we're in Windows and we go back to the game, it's not going to copy it. It'll copy it here in Windows. I can paste it in Windows, but not into the game. So all we got to do is remember we need 4 sets of CUs. So we're back here. It's saying, hey, enter the short key of a shape, which you can generate here. We need to type in, make our own circle. C, which is capitalized, U, C, U, C, U, C, U. It went from pink to white. Now that was in there. It would have been nice if I could have copied it and pasted it in here, but you can't. Because some of these get pretty confusing when you get more layers in here. But remember, we're at one layer only. So we're going to hit OK to that. Now look. Oh, wait. What? Whoa, something's happening. What happened? Well, it's working now. Look what happened. Look, only circles are going at the top. We're filtering. So this is our first application of using a filter as a filter. We're taking all the circles, which was our desired part that we wanted, and we're sending it to where we want to send it. To let them machines manipulate it, chop it up, cut it up, do whatever you want to make this shape. So if you look at the electronics again, that's how an electronic signal, which is virtual, it's down below, is actually controlling the part. And this is just nice to see, and it's going slower because I don't have, my extraction tool is on only 1, so it's extracting slower, so it lets us see things easier up here. Now, okay, this filter is doing its thing. What would happen if I was to take this trash can away? What's going to happen to this assembly line that we have going here? If you remove the trash can, Well, eventually, this output, which is not circles, is going to get backed up. It's going to say, hey, I got nowhere to go. It's getting backed up pretty quick. Now, since its output has nowhere to go, this thing gets backed up. It says, I got to stop. I got nowhere to send my parts. That line is clogging me up. Let's put our trash can back in. Now I have I got an endless place to send stuff. Absolutely. So now, what happens if we take this one away? What happens if we take the circles trash can away? By deleting it. Oops. Houston, we've got a problem. But that makes a lot of sense. That makes sense. Because it's got nowhere to go. It'll clog. That's why a lot of places in the game, when you got trash, you use the trash can. So let's put that back in again. Get things back to normal. Now, it's going to take a little bit of thought process to get this to start working for you. Now, in the game, what you need to do is make a huge machine that's going to be making decisions for you. This is just the most basic possible thing you can have. But at least it is doing something. The wiring layer is actually controlling real components. As you can see, they're being split up right here. So this is the first episode of how to actually make a decision by this device and its corresponding signal generator. These are super useful, these signal generators. Very, very usable, a ton. You'll use them a lot. Now, I did make a color mixer because what's going to happen in this game also is you're going to need a bunch of these electronics working in conjunction with routing parts to satisfy your output of the hub, which is here, and the electronics layer, which is here. These decision makers are taking your signal and analyzing it with these devices, and you need to rotate it again to analyze it again and analyze it again and analyze it again. So this is a virtual rotator. And you have these parts, and then you analyze each of these pieces. Look at this one has a star on it. That one's got a circle. That one's got a circle, and that one's got a star. And that one has a yellow, and that one has a white. So we're actually looking at some of these pieces already. You know, you got the yellow and the white at one level. This must be the inner layer. So yeah, if you look here, we got a star, yellow. If you look at the part, we got the star, which is yellow. And up here we have the circle, which is white. We're analyzing it. And with these analyzed signals coming out, circle and color, we send this signal somewhere to start making decisions of what piece moves where by using our basic knowledge now of electronics. And it's going to take some time and some practice to get to that point where you start going, oh, I see, okay. Then you realize how big this machine is going to be. Because this is just one layer. There's going to be 4 of them, and you have colors. Now, to see the color maker, eventually you're going to need to make a machine that makes any color necessary on the fly. It's got to do that. Because remember, this has to be automatic. So when these analyzers analyze a color and send it out, that out signal needs to go to some color generator somewhere and make that color and paint that part. So let's take a look at a color mixer that I made, and it's automatic. I'll show you this. Now this is a bigger piece, but it works the same as the more condensed one that I made. But this is kind of cool to see happen. It really doesn't matter how big it is if it's, unless it's ridiculous. But this is a color mixer, and I've much since compressed it down. And what I did is I set up a set of buttons over here. Now in real life, the buttons are going to be replaced by an input signal coming from the analyzers. So there's going to be a wire coming over here, and it's going to touch and come into the signal electronically. Right now we just have buttons, but that signal would then be applied to every one of these switches. And when the proper color is sent, the proper switch will be energized or turned on, basically. And in this case, I have a manual one. This is a manual one. But remember, your wire will be coming in and paralleling all these together with a color. See, we have cyan, we have red, we have purple, green, yellow, blue, and white. And when I manually push the button, it manually sends the 0 out and sends it into a 1 and turns on a set of switches and filters which tells this painter to paint that color that I pressed the button. This is just a graphical way of looking at it. So let's take a look. Our output just so happens to be coming down this row here from this device. So the colors are fed in. Our three main colors are coming in over here. Our red, our green, and our blue, and they're coming into all this stuff. And they're coming through. And there are some electronic decision makers going on to tell certain filters to turn on and off, whatever. You can get real hairy with this stuff. So let's see what happens if I push white. Look, it's painting white. And I did put in an extra display screen right here. Now, of course, right now it's stopped because it's going into another mixer. So I need to get this one out of here for now. And we're just going to go like this. Oh, backwards. There. All right. Now this is a reader here that's saying, hey, we got this kind of white coming through, so this is a display that turns on. Notice I push white. Or I applied a white signal in here. So if I stop pushing white, the white stops, and let's just push blue to see what happens. Here comes blue. Now blue is coming through. Its corresponding displays come on. If you look at the electronics, there's a reader that whatever's going by the reader sees it. It sees blue, and it sends it out and it puts it to the display monitor. It's nice just to have a graphical color representation of what color you're spitting out. So if we stop that, go to, say, green, and we'll start getting green. Comes our green. Hey, what would happen if we would push green and purple at the same time? Well, just like you think. Green and purple. This machine spits out whatever you tell it. But anyway, turn these off. This is another type of machine that needs to be made for the big machine. And make sure you make it condensed enough, and you'll make copies of this because you're going to use it over and over and over again. That's why I don't want to make the big machine, because I don't want to waste a month making it. But I know I don't know, there may be 1,000 levels in this game. And I don't want to do them all the hard, slow way. But anyway, aside from all that, that's it. So I'm going to go ahead and quit the video. I know it was kind of stretched out, but you know what? If you try to talk big and if you're talking to somebody that doesn't get it, you gotta the whole idea of the video is that somebody can get it. Oh, that's the whole point. Not to confuse them by doing too much stuff. Now, obviously, if anybody can get to this level, I'm only at level what? Oh, I don't know, 28. Anybody can get to this level or past this level has a good understanding of this game. Or let's go to the hub. Yeah, I mean, once I got to 26 and I finished it and then got all the electronic parts, I went, wow, well, what am I going to do with all these now? And then they recommend in the game that you make your own machine that makes the next level for you. And then I went, oh, whoa. This is going to get big. So now I see why they threw all these extra pieces in here. I see. I went, whoa. Okay. Well, I'm going to go ahead and quit the video. And, but you can have some fun in here aside from the fact that you make the parts that they required. You can play with some of those decision makers and have some pretty cool, if you can conjure up some neat designs of your own and make some pretty cool stuff. All right, but anyway, I'm going to go ahead and sign off. And that'll be it. All right, you got the Sissy signing off. Later. See ya.